Good morning, everybody, and welcome back to Math 105. Plan for today is we're going to have our discussion about what I asked you all to think about for today, kind of what is to you is math. But my plan is to kind of see what your all's thoughts are, and then I'll talk a little bit about what my thoughts are on what math is. And then we're going to jump into our first learning standard of the semester and start talking about what does it mean to make a mathematical statement. My next office hours, which will be on by Zoom, are going to be on Monday morning from 10 to 10:50 and Monday afternoon from 2 o'clock to 3 o'clock. And there's not going to be any homework for you for over the weekend. Kind of the next homework set will be once we finish talking about this learning standard, which I'm expecting to be on Monday, will be to complete kind of the first standard quiz online. But I'll talk about that on Monday. So one thing I didn't mention last time is that I always like to start class off with a joke of the day. What did 0 say to the number 8?
It will spoil it because I've heard this before, so do you want me to not say it?
Oh, you can go ahead and say it. I thought about it now.
Nice belt.
Nice belt. Looks a little tight around the waist, though. Okay, so after our first class on Wednesday, I asked you to start to think a little bit about if you had to sum up in a sentence what is math to you, what that would be. So I thought we'd start by just seeing I would start by seeing kind of what you all thought about math, and I'll kind of make a list up at the board. And now this is something you don't necessarily have to write down or anything. These are not going to be mathematical statements because they're opinion-based. Talk about what that means in a bit. But thought it would just kind of be nice to have like a list of what your all's thoughts were on this. So would anyone like to start us off?
I thought about it. I realize it's probably a bit too broad, but I'll just say it anyway. I thought it is the study of reasoning and using proofs to discuss those reasons.
So the study of reasoning and using proofs to
Discuss those reasonings or contemplate those reasons or refine. I don't know.
refine our reasoning. I like that. Okay. Ooh, nice. I like that. It's actually not too far from my own.
To me, it's the means by which I make somewhat order in a disorderly world.
Ooh, to make order in a disorderly world. I like that.
Study of numbers.
Numbers. There we go.
A maybe frustrating puzzle of how the world works.
A maybe frustrating puzzle of how the world works. I like it.
It's a bridge to truth because it connects like the abstract of numbers to reality.
Ooh, something that connects the abstract to reality. That kind of gets nicely into the dichotomy between kind of the two main branches of math, theoretical math versus applied math. I like it. To connect. Yeah.
I said the use of equations, numbers, and letters to properly justify the physical world.
equations, numbers, letters to, I'm sorry, what was the second half?
Justify the physical world.
Justify the physical world.
I had that math is kind of a medium or one of many mediums to express reality, although that might not work for theoretical math.
Nonsense. I think it totally works for theoretical math.
Um,
You just have to define what you mean by reality very carefully.
oh, it's too early for that. Yeah, and I had like specifically to numerals, patterns, and the logic that governs them, but it's pretty much covered just as a medium to express reality.
Let's get two more.
One of the things I had was a study that pertains to the big questions, what can and can't be. So like a square just can't be a triangle.
Study of the big questions of what can
Or cannot be.
and cannot be. Thanks. Actually lead in very, this one I think leads in very nicely to what we'll be talking about in the second half of class today.
A kind of language that describes the reality of the world. You remember what it describes? What kind of language?
Language to describe something.
Yeah, reality, world, logic.
Sounds good. Anyone else want to do one last one?
I said the overly complicated study of quantity, geometry, and forms.
Overly complicated. Geometry, quantity. You have one more?
And forms.
And forms. Okay, nice job. Y'all had some really well thought out answers here. Okay, I think I agree to all of these. That all of these kind of describe to me different ways of thinking about math. Here's my answer. I came up with a couple answers because I was excited. So mine was a way of thinking logically about the world in a way that lets us discover truth. So when I interviewed for my job here a couple years ago, as part of my interview, I had to meet with Dr. Arn. As I was sitting there squirming in his office, he actually asked me this question: "What is math?" And I had to come up with an answer like this on the fly. And I think I came up with something like this, like just a way of discovering truth, a way of thinking logically by means of finding patterns. And ultimately, finding patterns, thinking logically was what I was able to come up with. But honestly, I feel like my answer definitely kind of encompasses all the answers that you all were thinking about. And that a lot of these are kind of different ways of saying the same thing I did, or maybe individual aspects of what I did. Like numbers, for instance, or maybe frustrating puzzles. I like that. Because math has frustrated me in many points in my life. A language to describe something. Means by which we can express reality, whatever that may mean. I think all of these were great answers, and all kind of hit at the aspect that math is there's some sort of truth-seeking to math, that it's not all just going to be about numbers and equations and abstract squiggles on a board, which, to be fair, are all definitely a part of math, especially kind of early on in your life, like using numbers as kind of a tool to express truths about reality. If you take two things and two things, you get four things. That's certainly a truth about reality that would use numbers. But I think that math somehow kind of extends beyond just the world of using numbers as well. And ultimately, to me at least, it's kind of a way, it's more a way of thinking than a way of learning my times tables, so to speak. Because like I said, on the first day of the semester, or on Wednesday, we're not really going to be doing hardly anything with numbers in this class, except as kind of an occasional example to help illustrate a point. And that's not going to be doing much with numbers. We're going to be doing very little with equations. And what we're going to be doing in this class, I think, I would say falls under this category. We're going to kind of discover what can and cannot be. In other words, what sorts of things can we discover as truth and which things can we not. Yeah, nice job with this. Thought it would be nice to kind of start this class off with this thought exercise, sort of a way of kind of getting under the same page and helping me express what I think math is to you. Does anybody have any questions or comments before we jump into our first practice? Okay, in that case, I'd like everybody to go ahead and get their standard one packet. I put my copies, put a bunch of copies at the door, so make sure you've gotten your copy of that. This eraser stinks. There we go. That's a little better. So each time that we start talking about a new standard, remember we had these 20 standards we were going to work through this semester. For each one is going to have its own note packet, which I'll always leave at the front of the room before class for on the day we're going to start a new standard. This is something that you can use to help you take notes if you'd like. You're welcome to use this. You don't have to. If you just want to take your own notes in a notebook or something, that's fine. These will typically have like lots of examples and a little bit of space for you to kind of work them out and think about them. But this is not something you're ever going to have to turn into me or do anything fancy with. So take this as you will. And once we finish talking about an individual standard in class, I'll post solutions for the note packet on Blackboard, which, since we're not going to cover every single question in these packets during class, they'll kind of give you a way to try doing some extra practice problems on your own, and then later on after class, after you've looked at all the questions, you can then go and kind of check your solutions outside of class. See attention there. So first standard is all just kind of going to be about what is a mathematical statement. And I'm going to use the word statement and mathematical statement interchangeably. So when I refer to something as being a mathematical statement, it might not have anything to do with what you've seen before in a previous math class. Like I might make a statement about George W. Bush being the president of the United States and call that a mathematical statement. So, statement is just going to be a sentence that is unambiguously true or false. So, sentence, like you've seen before in countless classes, something with a subject, something with a verb. And we want to say that it's unambiguously true or false. That if you had more knowledge than maybe you currently do about how the world works, you could point to that sentence and say, that has to be true, or that has to be false. But a key part of this definition, I think, is the word unambiguously. Meaning, it has to kind of be agreed upon by everybody. There can't be kind of multiple perspectives to look at something and say, well, from one way I could see how it's true, from another way I could see how it's false. Let's start off. I want to start off by talking about a few examples as a group, and then I'll give you all a few minutes to kind of look at a few more examples on your own. And what we're going to do with these examples is we're going to try and determine, do each of these examples constitute a statement, something that's unambiguously true or false, or is there not a statement to them? Let's look at a few. Michigan is a state in the U.S. What do you all think about that?
It's a statement.
It's a statement? Why is it a statement?
You can't debate about whether it is a state or not. You can debate, is it a good state? Is it a useful state? But you can't debate, it is part of the USA.
Well put. Yeah, there's certainly, if we were to put some adjectives in there, maybe we could get something that could be debated. But you ask someone who has a good sense of, you ask someone who knows what a state of the United States is Michigan a state? They should be able to tell you, yes, it is. So I would say that this is a statement. Yes, it is a statement. And we can assign a truth value to the statement. We can be able to say, we could be able to give this a state value of true or false. In this case, I think you said the answer was?
It's true.
It's true. This one is going to be a true statement. How about this one? The Mona Lisa is a beautiful painting.
Not a statement because it's ambiguous.
It's not a statement because it's ambiguous. What does the word beautiful mean?
It's subjective. It's an adjective.
It's subjective. It's in the eye of the beholder, meaning what I might think is beautiful might be different from what you think is beautiful. So this one is going to not be a statement because it has some subjectivity to it. You might look at the Mona Lisa and think, that's the most beautiful thing I've ever seen. I might look at it and think, I don't like the looks of this thing, it's creepy. Its eyes keep following me around. What's up with that? You ask two different people about the sentence. To some, they might say, yes, I agree with this. To some, they might say, no, I disagree. I think the general consensus is, I think most people would say, yes, it's a nice painting. It's a beautiful painting. It's a very famous work of art. But just because it's the general consensus doesn't mean there's not any subjectivity to it. So just because most people might say something is, just because most people may agree with a sentence like this doesn't mean everybody will agree who has an informed opinion on the matter. And so they might say, and so some people will disagree, and that makes it a subjective statement. Now, for something like Michigan is a state in the United States, you could have someone who doesn't really know what a state is. Like you ask a 4-year-old, is Michigan a state in the U.S. who's never been outside their hometown before? And they might say, no, that's in the far-off, scary place. You may get some people who disagree with Michigan being a state in the U.S., But there is a key difference still between this sentence, and that is this one, there is a well-defined definition for being a state in the U.S. I'm a math professor, not your politics professor, so I don't know what that statement is. I come from Kentucky, which isn't even a state, it's a commonwealth, so what do I know? But I could say here is a definitive list of 50 U.S. states. Michigan is on there, therefore Michigan is a state. And all those with who know what it means to be a state, which does have a well-defined meaning, would say true to this. How about this next one? 3 is an even number. It's a statement? Why?
It's not ambiguous, but it's false. It's known that it's false.
It is unambiguously a false statement. We have a well-defined meaning for what it means for a number to be even, and 3 does not satisfy it. So I'm going to say yes, and the yes is to the yes, it's a statement, not yes, it's 3 is an even number. But it is unambiguously false. 3 is not an even number. Even number we can define to be a multiple of 2, an integer multiple of 2. 3 doesn't satisfy that. 3 is not a multiple of 2. You know what an even number is, you can unambiguously say that 3 is not even, and therefore this is a mathematical statement, albeit a false one. Do one more on this page. X is an even number. Let's see. Yes.
It's not a statement because X could be an even number or it can't be an even number, so it's ambiguous.
Yeah, I never said what X is. I mean, you could say X isn't a number, silly, it's a letter. Well, if we refer to a variable like X, we're assuming here that X is a variable that's used to refer to numbers and not, I don't know, middle names of all of your family members. But unless we establish exactly what X is referring to here, we can't say whether this is true or false. You might say, I'm thinking of X equals 6, which would make this statement true. Whereas I might up here say, aha, but I was thinking of X equals 7, which makes it false, sucker. But we haven't actually established what X is. Unlike over here, where we could say 3 is an even number. Yes, that is something we can unambiguously say is false. Without knowing what X is, we can't say true or false. Not a statement. We can't establish truth. Or falseness without knowing what X is. So what I would like for you all to do now is I want you to look at the second page of this handout where I give you 4 more sentences or sentence-ish things. And I want you to take a couple minutes and see if you can work through on your own whether you believe each of these 4 sentences are statements or not. And then we'll come back together in a few minutes and talk about them as a class. Okay, when I get you work to do, I need to make a quick announcement before you get too deep in. By strong own tendency as a teacher is to tell you, work with the people sitting around you, use them as a resource, bounce ideas and such off them. COVID. If you and the other people sitting around you feel comfortable talking to each other, I will allow you to do so. But if you don't feel comfortable, then please don't. I kind of think the policy I've established. Normally, I would also kind of do a lot more walking around the room, listening to conversations. I'm going to stay up towards the front. But if you have a question for me, certainly raise your hand and I'll come as near as I can. Oh, I know. Intentionally so. Also, alternatively, I disagree and don't think that the last one is being, what you just said is not a statement.
I said it's a statement. Because I mean, you have to like, you have a pretty defined subject and.
Every statement was I guess it's not an inclusive. Yeah, that can be true. Yes, it's not false. It's either true or false, but we don't. So that's yeah, but we don't know. So we don't know. I think we
You gave remember the name of something?
Yeah, I remember the last time you sent it.
Starts with a P.
Oh.
Not postulate. We will be talking about lots of postulates later in this semester and what that word means.
It's been like years. I think it's been like 3 years since they've been getting
But I can't look for.
I think exactly.
It's been many more years since I took any class.
So like you have to either know.
So let's come back together for a couple minutes here. Sounds like you all have had some good ideas in looking at each of these sentences. How about Hawaii lies in the Atlantic Ocean? What do y'all think? It's a false statement. I agree. I'm going to say yes. It's a false statement. Hawaii lies in the Pacific Ocean. It does not lie in the Atlantic Ocean. The property of lying in the Atlantic Ocean is an unambiguous property. It's not like simultaneously straddling the border between the Atlantic Ocean and something else. So I think we can agree that this is going to be a false statement. Good golly, Miss Molly, one of my favorite things to say, up there with awesome possum and neato mosquito.
So I put that this is not a statement because it's an exclamation, and so it doesn't really carry any weight of information or truth. It's just kind of putting it out there. Good golly, Miss Molly. I haven't really said anything. I just exclaimed.
You haven't really said anything that conveys any sort of truth to it. So they're just saying something that's fun to say, but ultimately rather meaningless.
It doesn't make a claim.
Doesn't make any sort of claim.
It's not a sentence.
Earth going on.
True. That is not a sentence. It is a, if I was an English teacher, what would I call it? An exclamatory remark, I think is how you put it. But I think I would agree with that, room for all the reasons you said. This is not a statement. And the reasoning is it doesn't put forth any claims that can be verified as true or false. Yeah, I think I would agree. Life exists on Mars.
I said it was not a statement. We don't have enough information. It's ambiguous. I say we could either, there could be life on Mars or there could not.
Gotcha. You're saying it's not a statement because
We haven't explored Mars enough to know fully
we haven't
what
mapped
it's
every,
capable of.
we have not mapped every cubic centimeter of Mars and what lies beneath the surface.
Exactly.
There could be or there might not be.
So I'm kind of torn on this because does the statement and the truth or the the truth value of it have to lie within our knowledge? Or can it be something we haven't discovered yet? Could we say it's a statement and that we just don't know the truth or false of it yet? Because it does put forth a claim.
That's a good question. This is certainly something that puts forth a claim. So if it's not a statement, it's for different reasons than good golly, Miss Molly. Let's go. Sometimes when you're not quite sure if something fits a definition, I find it helpful to kind of go back and reread what does the definition actually say. So a statement is a sentence that is unambiguously true or false. Does the definition require that that any reasonable person knows that it's true or false, or just that it is true or false? The definition doesn't necessarily say we have to know, or everybody has to know if it's true or false. It says it has to have an unambiguous truth or falsehood value.
So, oh, sorry.
I'll come back to you this time. Thanks for chiming in.
Okay, so I would ask then, like, if people don't know it, then wouldn't it be ambiguous?
What do we mean by ambiguous? I would argue ambiguous is something that is being something that doesn't have a well-defined definition. Something like being beautiful, or being cool, or I'm having a hard time thinking of the ambiguous things that I'm trying to say are funny and can be made a joke of.
So could this be unambiguous because either life exists or it doesn't? There's only two options and each one cancels out the other if one is true?
Good question.
And this isn't a science class, but then we could get down to the definition of what is life. You know, some people believe that, a baby inside a woman isn't life until it reaches a certain point as more than just a cell. I do know that on Mars they found frozen bacteria, which would be considered life here on Earth, but if you don't consider a baby growing inside someone to be life, then the definition of life itself is ambiguous and depends on a person and therefore their opinion. So the statement could be true or false depending on what a person believes life is.
This is true. We have to assume in order to be able to say there can be truth or falsehood to this value, we need to assume that there is a definition of life that is commonly agreed upon. Which I don't want to get into what that is in here, but I totally agree with what you're getting at.
That said, no matter what we believe life is, it either exists or it doesn't. It cannot simultaneously exist and not exist.
I'm just saying it's ambiguous and that depends.
You don't believe in Schrodinger's cat? So you're all making some really good points here. Here's what I would believe. I would believe this is a statement whose truth or falsehood is something we don't know. If you define kind of old petrified bacteria as being life on Mars, then as being life, then I would say yes. If we think about something as being like moving about something, multicellular life. I should have done some sciencey research before I gave this question, you're making me realize. I would say we don't know the answer to it, but that doesn't necessarily mean it's not a statement. That doesn't make it ambiguous, that just means we don't have the knowledge to determine if it's true or false, but that there is still an unknown truthness or falseness to this statement that is unambiguous. We just don't have all the information needed to be able to say, aha, true, or aha, false.
So how does this differ from the statement we looked at where x is an even number?
Sorry, let me write this down really quick and I'll get right back to you. Okay. This is yes, a statement, but one. We don't know if true or false. Good question. Let's go. So let's think back to x is an even number. How is this? How would we say that this sentence, life exists on Mars, is different from x is an even number in a way that would make x is an even number not a statement, whereas life exists on Mars would be? Oh, sorry, I thought you answered that.
I mean, life either exists or it doesn't. It doesn't matter what we define it as. At some point, life will exist on Mars. With anybody's definition, if it exists, and if it doesn't exist, then nobody's definition matters because the statement will be false. But with x, and we could all have a different value of x in our head, and then so it could the statement could be true for one of us, but not true for another one of us.
But could we all have a different definition of life in our head?
Yeah, but at some point that life will be.
Well, at some point, x is a number, and we have math to figure out what that number is. So at some point,
Yeah,
one of
but
us will be right and
If
one
I
of
have
us will be wrong.
x is 3 in my head, then it's never going to be a number.
Well, I
But
mean,
if someone else says x is 2 and that turns out to be the thing, then it will be an even number.
But it doesn't give us, it's not, how could it turn out to be a thing since the question doesn't tell us what x is?
if you're not talking about
It's subjective to everybody.
Both making really good points here. Let's hear for some others.
X is simply not defined at all here. There's not debate about the definition of it. If we were to substitute anything for X or define X, then it would change the entire statement.
I would agree. I think here, and I purposely tried to give you a sentence like this that is both ambiguous and unambiguous at the same time. How do we define life? Because I really want to stress the point that oftentimes in math, mathematicians will disagree on a definition, and if you disagree on what the definition of something is, the sort of claims and statements that you can make are going to be very different than what the definitions are from other people. Which is why I think in math and the sciences in general, it's always going to be very important to have a clear-cut definition that you're working with. Like, here is what we define a Hopf algebra to be. Oops, sorry, got in my dissertation mode for a second. Here is what we define life to be. It's important to have a definition of something like that you have to go off of. So I'll also add a caveat to this, in which the caveat is going to be, this may not be a statement if we don't all agree on what it means on a definition for life. So throwing that in is a bit of a caveat, in which if we had a clear-cut definition for what life is, this would be a statement. Don't worry, I'll try it. I won't ask something as ambiguous as life exists on Mars on like a quiz or anything. I just wanted you to kind of think about it a little bit deeper as sort of a classroom exercise. So how about this last one? This sentence is false.
I said it's not a statement, because it's a little ambiguous. Is it talking about that sentence? Is it just talking about a different sentence?
Good question. Do we necessarily know what sentence we're talking about?
Right.
Let's say we're assuming that this is making a claim about itself. This is a sentence that claims that itself is true or itself is false. Would that change your answer?
Yeah, in which case I'd say that is a statement.
It is a statement.
And I'm not gonna broach whether it's true or false.
That's quite a pickle to try to determine.
I said there wasn't a statement because it's paradoxical.
Paradoxical, what does that mean?
That its center, whether or not it has any truth value, can't basically exist and be true because of what it says about itself.
Let's see, if this sentence is false as a true statement, then it must be a false statement. But if it's a false statement, then it's not false, and therefore it's true. Uh-oh. So a couple other hands over here, I think, out of the corner of my eye. Did anyone want to comment on that before we kind of come to a conclusion?
I was gonna say the same thing about the paradox.
Yeah, saying it was contradictory, so it can't exist, it contradicts itself.
Yeah, it can't exist, it contradicts itself. And can you repeat kind of the word you used to refer to a sort of sentence like that is self-contradictory?
Paradoxical.
Paradoxical. Yeah, I would say something like this is not a statement. And I would say, logically speaking, it can't be true, because if it was true, then it's false. Then it has to be false. And it also can't be false, because if it's false, it has to be true. You can't assign a truth or false value to this sentence without causing some sort of logical contradiction. It can be either true or false without causing a contradiction, a logical contradiction.
So, sorry. So is that just like having an equation that says like 3x equals 5x? Like you can't plug in anything for x that's going to make the statement true, or the equation true?
What about x equals 0? How about x plus 1 equals x?
Yeah.
There's nothing you can plug in for x there that'll make that equation true. I would say something like that is not a statement, more along the lines of the same reason we can't say x is an even number as a statement. It's like although that one doesn't depend on what x is, since no x would satisfy it. Well, let me think. I wasn't prepared for this one. X. So if you have an equation that has no solution, I would say something like that you would always consider to be false.
Okay.
It's false no matter what you plug in for x. Therefore, that I would say is more of a false statement. Because it doesn't matter what your frame of reference is, what value. If we're all thinking of different values of x, for all of us, it would still be the case that whatever you plug in for x plus 1 is not going to be equal to x. So that would be a statement that is always false. Whereas something like 3x equals 5x is false in every case except for 0. I would say that's not a statement because in that case, it depends on what you want your x to be. Good question, though.
What if x is a Roman numeral?
What if x is a Roman numeral?
Which would be 10?
All right. I was going to save this joke for later in the semester, but why was algebra so easy to the Romans? Because x is always 10. It's true. We have to assume that when we refer to something like x, we're thinking about a variable that takes on. We have to assume we're all coming from the standpoint of, all right, we're going to assume that x has to be some, let's say, real number. Otherwise, we can go down the rabbit hole. Technically, I think with any statement, you could try to twist your definitions enough so that any statement can be made ambiguous if you really wanted to. So that's why we kind of all have to, at some point, come together and agree that, okay, we're going to assume we're going to assume we're working from a point of reference where here's what something like X is allowed to be, and here's what something like X is not allowed to be. And I'll try to make those clear. And when we get to talking about Euclid, we're going to see how Euclid didn't do that carefully enough, and so he got into some trouble and mischief.
So like, for example, for the Hawaii lies in the Atlantic Ocean, we could argue that since all oceans are connected, it's all one ocean, and therefore it should be called the one ocean, and therefore that's like, just like you could argue that maybe the Atlantic Ocean and the Pacific Ocean should be one ocean together.
Exactly.
Or maybe the Pacific Ocean should become the Atlantic Ocean because it's connected, and so we'd have to have the same point of reference of understanding geography.
Bingo. This would be another case of you could twist your definitions of what the Atlantic Ocean is enough to be able to say, aha, I've come up with a new definition for ocean under which this is false. Therefore, since we can't agree on a definition, this is not a statement.
It's connected.
You could do that. You could certainly do that, but from what is commonly understood to be the Atlantic Ocean, 9.9 out of 10 scientists will agree Hawaii is not in the Atlantic Ocean, so this is a false statement, as opposed to something that has ambiguous truth value to it, in which case, yeah.
Does that mean some of these questions won't actually have the right answers and wrong answers, as long as we can sort of rationalize our answer be correct?
Bingo. Later on in this, so if I ask a question like this, gosh, I can tell I'm going to have to be very careful with writing my quiz test questions around you all. If, let's say on a quiz or something, I give you something that I think is unambiguous, but if you are able to come up with something like what you just described, say, aha, but all oceans are really one, and there's no clear borders between them, therefore it is in the Atlantic Ocean. If you were able to come up with something like that and show me that you were kind of logically thinking about what it means for the definition to be satisfied, I would give it to you, even if it wasn't what I had in mind. Especially, I want to make it a really good point for why in the second half of the semester it's really clear why when we're defining an axiomatic system for geometry, we really need to nail down very precisely all of our definitions and all of our starting assumptions before we can kind of work our way forward from there. Good point. I forgot to write this down, but I would say this is going to be a paradox. A paradox in that it being true or false, either being true or being false is a contradiction, logical contradiction to it. If it's true, then it has to be false. If it's false, then it has to be true. That is going to be what we're going to call a paradox. What does a mathematician call a couple of surgeons? A paradox. No, I actually have an entire math joke book. Wait, no. I have an entire joke book full of like that sort of like similar level humor. Both that and the X is always 10 come from that book. I need to be careful with the jokes I tell or I'll run out by the end of the semester.
Can we get extra credit for putting jokes on our tests?
Oh God.
Only if you've never heard it before.
So I'm going to tell you a brief story about when I was in college. So I took a math class in college where the professor said, all right, if you're able to, I'm looking for some good math jokes about some good Chuck Norris math jokes so I can give to my sister. If you, I'll give you extra credit for each good one that you came up with. And then I came up with like literally like 20 for the next homework assignment. Like, okay, I'm now setting a limit on this. So no, you will not get extra credit for jokes, but it will put me in a better mood as I read your things, and being in a better mood can't hurt your grade.
What if it's like a really, really good joke?
We can talk. Great. Any questions? Any questions about any of these? Okay, that's going to do it for today. When we come back on Monday, we're gonna work our way to the last few pages of this worksheet, talk about the negation of statements and what it means for collection of statements to be contradictory.
So leave these two pages in.
Yes, the last several pages are going to be for Monday's class. If you want to think about them now, you're welcome to do so, but we will plan on talking about them. Nice job, Dave. All came up with some really good ideas and viewpoints here.
Yeah, that's right.
Even though I totally like.
Exactly. Right.
Do you need to do any more studying? I'm going right to the library after this because I have very many questions. So it's